Graphing linear equations in standard form. That's just ax plus by equals c, where your x and y values are your variables, and of course the a, b, and c values are just your numeric values. So for this first example, our a value is the number 3, our b value is a 2, and our c value is a 12. That's all that standard form means. Now, we already know how to graph a linear equation in slope-intercept form. And if you don't remember how to do that, I would encourage you to go find the video that I have posted for you. But here we are in standard form. So we can definitely rearrange it and put it in slope-intercept if we want to. Or there might be a simpler way of graphing these functions if they are in standard form. First, I want you to remember what an x-intercept is. An x-intercept is just the point where a graph crosses our x-axis. So if we have a point sitting on the x-axis, no matter what that x value is, the y value has to be 0, right? Now, a y-intercept is very similar. That is just where our graph crosses the y-axis. And if we have a graph or a point on the y-axis, that means the x value has to be 0. So every single x-intercept is going to be written in the format of x comma 0, and every single y-intercept will always be 0 comma y. All right, so let's use that information. 3x plus 2y equals 12. If I want to find my x-intercept, I am just going to substitute in the number 0 for my y variable right here. So let's rewrite this. 3x plus 2 times 0 equals 12. Well, what's 0 times anything? It just gives us 0. So this 2 times 0 just cancels out. And we're left with 3x equals 12. So let's isolate our x value. We divide both sides of our equation by 3. And we end up with x equals 4. So I know I have an x-intercept at positive 4. So let's go down to my x-axis right here and find 4 on the x-axis. 1, 2, 3, 4. And I plot that point right there. That's my x-intercept. Now to find my y-intercept, I am going to sub in 0 for my x value. So I'm going to sub in 0 right here for my x value. Instead of 3 times x, we have 3 times 0 plus 2y equals 12. And of course, 3 times 0 is just 0, so we're left with 2y equals 12. And we can divide both sides by 2 here to isolate our y value, and we get y equals 6. So on our y-axis right here, I am going to plot the number 6. And now I have 2 points, which is all I need to graph a line. So I'll just draw a line between these 2 points, put my arrows on the end, and we're done. All right, let's try another one. Minus 2x or negative 2x plus 5y equals 10. So if you want to start with your x-intercept, and it doesn't matter if you start with x or y-intercept, I just always do the same thing over and over again. So let's find our x-intercept, and we'll plug in 0 for our y value. Negative 2x plus 5 times 0 equals 10. Well, 5 times 0 is just 0, so we end up with negative 2x equals 10. And we'll divide both sides by negative 2, and that gives us x equals negative 5. So on our x-axis, I'll go to negative 1, 2, 3, 4, 5, and plot a point. And we'll do the same for our y-intercept. Instead, we will substitute in 0 for our x value. So negative 2 times 0 plus 5y equals 10. Negative 2 times 0, of course, gives us 0. 5y equals 10. So we'll divide both sides by 5. And that is going to give us y equals 2. So I'll plot the point right here at y equals 2, and then connect my 2 points with a line, Draw my arrows on the end, and there we have it. Let's do one more example. We have 2x minus y equals 6. So if I want to find my x-intercept, I'll go ahead and plug a 0 in for my y value. So 2x minus 0 equals 6. Of course, minus 0 does nothing for us. It just cancels out. We'll divide both sides by 2. And that's going to give us 1x, or just x, equals 3. So right here, we plot our point at positive 3 on our x-axis. To find our y-intercept, let's just plug in a 0 for the x variable. So 2 times x turns into 2 times 0 minus y equals 6. Well, 2 times 0 is 0, so that cancels out. Now we are left with a negative y, not just a y variable. And this one is just a little bit sneaky sometimes for some people. We kind of absorb this negative, or we ignore it and mess up the problem. You've got to remember that there's this understood 1 in front of your y variable. And in this case, it's a negative 1. So negative 1 times y. So our inverse operation, we need to divide by a negative 1. When we divide both sides by a negative 1, that gives us y equals negative 6. So on our y-axis, I think 1, 2, 3, 4, 5, 6. Ran out of space there. That negative 6 is way down there, and we'll just connect our 2 points. And there's our line.